Okay, welcome everyone. Sorry again for the technical difficulties. We're going to get going at this point. So thank you everyone for joining today, especially those of you who are here with us in Ann Arbor, but also thanks especially to people who are joining on Zoom. We hope to have, as we do in all these workshops, some good interaction between the people who are online and the people who are here in the room with us today. So thank you everyone for joining. My name is Brady West. I'm a research professor here at the Survey Research Center at ISR. I'm also the director of the scientific and technical core of the Population Dynamics and Health Program, which is who is sponsoring today's workshop. So very happy to have you here. On the screen, you actually see the PDHP website, and want to say a little bit about what PDHP does, and then we'll talk about kind of where these workshops come from. The Population Dynamics and Health Program is a research infrastructure program within the Population Studies Center here at ISR. So I've already mentioned two of the centers at ISR, so it's a pretty busy place, but administratively it's located within the Population Studies Center. And PDHP is essentially charged with providing research support to individuals and affiliates of the Population Studies Center, helping with grant development, helping with development of current manuscripts, helping with revisions of current manuscripts, and just providing other types of research support to people who are doing external or internally funded research. So workshops are one of the many services that PDHP offers. And this is supported by a P2C grant from NICHD. So we certainly want to acknowledge that support as part of this workshop. But this is just one of the many services that we offer. Paul Schultz, who you hear from, who puts out announcements about the different workshops. He and I, collectively with one of our analysts, we provide consulting support. So if you're an affiliate of PDHP, we're happy to meet with you, talk about your research, talk about the papers or proposals that you're working on, and help you through some of those problems that you might be grappling with or some of your challenges. So there's information here on the PDHP website about how to become an affiliate if you'd like to have access to some of those services. We also help with funded research projects. So if you're looking for analytic support, data management support, something of that nature, PDHP is more than happy to help out in that regard. And you can get in touch with Paul or myself if you'd like to explore setting up those kinds of subcontracts to help with projects that have already received funding. So more than happy to do that. We also have an Ask Me Anything hour that's pretty popular that helps people. They can bring whatever questions they want about the research that they're doing, and PDHP leadership will provide answers and hang out for about an hour to help you with those problems. And you can sign up for that too, or look at the next Ask Me Anything session on the PDHP website. And we also have a rolling small grants program. So if you're looking to perform additional research or supplement your current research with software, or you're looking to collect a little bit of additional data or conduct a pilot project, we do have a small grants program that's rolling. So you can learn more about that via the small grants tab on the PDHP website as well. So lots of different stuff going on. We're very happy to hear you today, or to have you here today, but we wanted to say a little bit about what PDHP offers and make this accessible to everybody. So turning to today's workshop, we're very happy to have actually three presenters here today. We're going to give them each a brief introduction, and then we'll get into the workshop, but they're going to be rotating with their presentation. But if you have questions, for those of you online, feel free to unmute yourself and ask questions at any point. Those of you in the room, just raise your hand and ask a question, and you can direct it to the presenter that you had the question for, because we're going to be hearing from three different folks today. So, but yeah, feel free to ask questions at any point. And again, this can be part of the dynamic conversation related to today's workshop. So, okay, so I wanted to briefly introduce each of them, and I'll do this in the order that they'll be presenting. So our first presenter is going to be Libby Benson. Libby is a research assistant professor here at ISR and a faculty member at the D3 Center. Her research leverages data science, mobile technologies, and theory-driven approaches to develop personalized mental and physical health interventions, adapt to individuals' evolving needs in real time. She focuses on developing intensive longitudinal models of psychological and behavioral processes using ecological momentary assessment and sensor-based data. She uses this knowledge to personalize intervention content and delivery, including personalized feedback, AI-driven messages, and just-in-time adaptive interventions. The goal of her work is to advance methods for moving beyond one-size-fits-all interventions and improving access to support in everyday life. So really happy to have Libby here, and you can see that she has expertise in all the areas we'll be talking about today. Xiyu Zhang is a research investigator at the D3 Center here at ISR. She completed her PhD in the Michigan Program in Survey and Data Science at the University of Michigan. Her research focuses on missing data in micro-randomized trials with the goal of improving the design and quality of data used to inform future adaptive interventions. She's interested in developing adaptive mobile measurement tools that keep cancer survivors engaged in self-monitoring. And then third, we have Walter Dempsey. Walter is an associate professor of biostatistics and an associate research professor in the D3 Center here at ISR. His research focuses on statistical methods for digital and mobile health. His current work involves three complementary research themes. First, experimental design and data analytic methods to inform multi-stage decision-making in health. Second, statistical modeling of complex longitudinal and survival data. And three, statistical modeling of complex relational structures such as interaction networks. In the coming years, he'll continue to design and apply novel statistical methodologies to make sense of complex longitudinal, survival, and relational data sets. This work will inform decision-making in health by aiding in intervention evaluation and development. Prior to joining in these current roles, he was a postdoctoral fellow in the Department of Statistics at Harvard University, where he worked within the Statistical Reinforcement Learning Lab under the supervision of Susan Murphy. He received his PhD in statistics at the University of Chicago under the supervision of Peter McCullough. So you can see that our three presenters today have extensive expertise in the topics that we're going to be talking about today. I would ask you to ask them questions liberally because you have the collective body of knowledge in this area is pretty incredible. That we have in this workshop today. So please don't hesitate to ask questions. You've got a lot of knowledge in the room between these three presenters. So we're very happy to have them here. And thanks to all three of you again for being here today. Okay, so with that, I'm going to turn it over to Libby, who will provide the first part of the workshop. Again, for those of you online, please do keep yourself muted until you have a question, and then feel free to unmute. Paul is also going to be monitoring the chat. So if you'd like to provide questions or ask questions in the chat, feel free, and Paul will raise those with the presenters here in the room. Okay? Okay, so I will turn it over to Libby. Thank you.
Libby, just as a reminder, you are already a lavalier as well. You don't need to know if you don't want it.
Was it something?
Look. Up there. I got it.
Okay, thank you.
This is oh, you're good. Oh no, nothing else. System's just today. It's going in with ITS on Monday. All right, and Libby, if you don't mind, could you give me just a little quick talkie? Hi.
Oh, this one's yours. That's at the end. Okay.
Okay. Let me turn
One's here.
Okay. No bad touch, just hitting your button. You're live.
Yeah, you're in a good spot.
You can stand wherever you want. That lapel is going to, no matter where you walk in this room. And I'm just going to follow you from here.
Perfect. Hi, everyone. My name is Libby Benson. I'm so here today. Thank you so much to the folks at PHP for inviting us to do the D for all your persistent tech setup. Hopefully we'll be smooth sailing from here forward. So I'm going to kick us off. As Brady mentioned in his kind introduction, we have three different people to talk with you today. So we have three parts to this workshop. As a fourth part at the end, ending with a Q&A, but I'll put it on the chat. So off with part about introduction to adaptive interventions and sequential multiple assignment randomized trials. There will be a quiz at the end for this acronym. Okay, so our objectives. So first, we're going to kick us off with talking about adaptive interventions, including defining what adaptive interventions are, provide an example adaptive intervention to help me out with describing the different components in these interventions, and then discussing why adaptive interventions are useful. And then we're going to transition into talking about sequential multiple assignment trials, or SMARTs, including defining what these are, discussing why they're useful, examples of primary and secondary data, or secondary aims and analysis code, and hopefully at the end, ending with SMART sample size considerations and a few other examples. Okay, so let's dive right in. So adaptive interventions are an intervention design or frame. They're a protocol that guide how dynamic intervention about a person should be used in practice to decide whether and how to intervene. And a key thing that I want you to take away from this workshop is that these are an intervention design, which is not an experimental design. So knowing the difference between these two things is a key objective of mine by the time I get to the end of this particular talk. Adaptive interventions use time-varying information about a person to modify the type, dose, and modality of treatment or modality of treatment. And the goal ultimately is to address conditions that change relatively slowly. So these are more those slow changing psychological or behavioral processes. Adaptive interventions overall should be replicable and protocolized and also effective and evidence-based. And they have many different names, so you may have actually come across these in some of your prior reading or research, including adaptive health interventions, adaptive treatment strategies, dynamic treatment regimes, and so forth. Okay, so up on the screen now, I have an example adaptive intervention, and I'm going to walk through the different components in the next few slides. But in general, what we have here is an adaptive intervention focused on childhood ADHD treatment. And so this is loosely based off of done by Bill Pelham at Florida International University. And what we have here is that at the beginning of the school year, a kiddo with ADHD is assigned to have medication, right? And so then they go along for 8 weeks with this medication, right? And we have this 8-week time period because this might take a few weeks to kick in and really see how the child is responding. And then starting out at 8 weeks, we start to assess whether they're responding to the medication. And if they are, then we continue, right? Don't fix what's not broken. So continue with med. But for those who aren't responding, we're not going to keep them on that, right? It's not helpful. We know that. So we're going to try adding behavioral modification and see if that additionally helps. So this is just an example of how an adaptive intervention might look in practice, right? These are the rules for guiding decisions about what to start with and then what to do for people who don't respond. And another way that these can be shown is then statements. So this bottom figure is another way to show an adaptive intervention, and we'll use both in this talk. But essentially, it's the same information, but figured as an then statement. So if the responsive equals yes, then intervention option is continue with med. Else, if their responsiveness is not equal to yes, then intervention option should be to add behavioral modification. Okay, so now I want to unpack this a little more and show you all the different components in an adaptive intervention. And so the first element to talk about is the decision point. So decision points are points in time in which the intervention decisions should be made. And here decisions are made at the beginning of the school year and then also monthly starting at week 8. The second element is the tailoring variables, and this is information about the participants that's used to decide whether and how to intervene. And so here, the tailoring variable is the child's response status. And the child's response status in this particular study is measured using 2 different pieces of information, including an individualized targeted list of behaviors and then an impairment rating scale. And so the child in this study was classified as a non-responder if their score on the list of behaviors was less than 75%, and 1 or more domains such as school, family, or social interactions were identified as impairment on the rating scale. And so if any of those were true, then they were identified as a non-responder. If these were not true, then the child is identified as a responder. And so this brings us to our third element in this adaptive intervention, which is the thresholds or levels. And these are in reference to the tailoring variable. So you have thresholds or levels of the tailoring variable that differentiate in which different intervention options be. And so here there's 2 different levels, including yes or no. So is the child a responder, yes or no? And these guide what to do next in stage 2. The fourth element is the intervention options, right? So when we assess their response status starting at 8 weeks, we have two different things we can do, right? We can continue with their medication or we can add behavioral modification. Those are our two choices. It doesn't necessarily need to be that there's two choices, or there could be multiple things in those choices. It's however it's specified. And it could also be different doses, different treatment modalities, all sorts of different things. And so the next piece here is that overall, so we've gone through each of the individual components. And so the next key thing to notice is that this intervention includes adaptation. And so adaptation is generally defined as the use of ongoing or dynamic information about the person to decide whether and how to intervene. And the adaptation is a process that involves monitoring individuals to obtain information about the tailoring variables and using thresholds or levels to decide which intervention option to use. And the adaptation process is triggered by different decision points. So in the example that I was talking about previously, right, the two decision points are at the beginning of the school year and then also at week 8. And the adaptation process is generally guided by two different types of outcomes. And so the distal outcome here is the ultimate goal that the intervention is trying to achieve. And so in this particular example, the ultimate goal is to reduce classroom rule violations by the end of the school year. And the proximal outcomes here are the short-term goals the adaptation is intended to achieve and in order to achieve the distal outcome. And so here, these short-term goals, behavioral difficulties and impairment in the course of the school year. And so the overall idea here is that if we can reduce these behavioral difficulties and impairment during the course of the school year, that the hope is that we can also improve the end of school year outcomes. So why might we want to use an adaptive intervention? There's two big reasons. One is to improve the overall effectiveness of the intervention, and the other is to improve the overall resource efficiency of the intervention. And so when we're thinking about effectiveness, the point here is to increase the number of individuals who benefit from an intervention by delivering the right type of intervention at the right time while minimizing burden. And so here, if we start someone with med and we see that they're a responder, right, we already know it's the right type of intervention. But if we see that they're a non-responder, we know that we don't have it right. And so we give them something else in hopes that we can actually help them rather than having them go through a full school year, even though we know, after only a few weeks that this isn't an intervention that's working for them. And then there's resource efficiency. And here the point is to minimize cost and burden by avoiding unnecessary treatment. Right? So we could think about a scenario where we know medication is generally good. We also know behavioral modification-based treatment. So we could just give everyone both things, right, up front at the beginning of the school year. But that's expensive, right? Medication's expensive. Behavioral modification therapy, also expensive, right? And so can do that doesn't necessarily mean that that's the most resource efficient way to go about something. And so the adaptive intervention helps with that by making sure that we're minimizing costs. So overall, adaptive intervention is strategic and also resource efficiency. And so we're really trying to work towards doing more good than harm and also avoiding wasteful resources and overworking. Okay, so quick summary on adaptive interventions. They're an empirically based protocol that guide how dynamic information about a person should be used in practice to decide whether and how to intervene. And at the bottom of the screen, I have the two different schematics for how these are typically displayed, for, showing a decision rule about what to do when for someone. And so now that we have this baseline knowledge of what an adaptive intervention is, we're going to transition now into talking about how we might answer scientific questions about how to construct one of these, right? So we don't all just have an idea of what the adaptive, or we might have an idea of what it should be, but we don't know how to necessarily construct one just off the cuff. So the sequential multiple assignment is a way to provide an empirical evidence base for constructing an adaptive intervention. And so in this section, I'm going to define what SMARTs are, discuss why they're useful, provide a few examples of primary and secondary aims and analysis code, and hopefully get to talk about sample size considerations and some examples, but they're in the slides, so you have them just in case I don't get there. Okay. So you might remember when I first started talking about adaptive interventions, I made a big deal about how they're an intervention design. Now that we're moving on into the SMART world, I want the key thing that you take away here is that these are an experimental design, not an intervention design. And they're a type of multi-stage randomized trial where each stage corresponds to one or more scientific questions concerning the selection and adaptation of intervention options. And a randomization takes place at each decision point of interest, where some or all participants are randomized more than once. But it's also true that not all participants have to be randomized at each decision. We'll see more about that in a little bit. And in general, as I was mentioning, the results from conducting a SMART inform the construction of an optimized, protocolized adaptive intervention. And our goal in general is to inform the construction, right, of high quality adaptive here. So why use a SMART? We would use a SMART if we have questions about the selection and adaptation components in an adaptive intervention, and also concern more than one decision point in the intervention. So there's three common primary aims that one might do from a SMART. The first is to compare the main effect of intervention options. The second is to compare the main effect of second stage intervention options. And the third is to compare embedded adaptive interventions. And so I'm putting up now, I'm going to unpack this, but this is a visual of what a SMART might look like. And one thing I wanted to point out is that sometimes people say that they're going to conduct a SMART trial, which is redundant, right? Because the T in SMART stands for trial. So just wanted to give that little nugget. But this is a SMART, and it's an example of a prototypical SMART that can be used to address these three aim types that I was talking about. And so let's now in the next few slides unpack exactly what's going on here. So in this particular trial, I'm going to unpack this in terms of what happens with. We'll talk about how to actually analyze data for the three primary aim types. And so when someone enters the study, right, their first random probability to either receive medication or behavioral modification. And this happens at the beginning of the school year. And then starting at week 8, we're going to assess people to determine whether they're a responder or a non-responder. And then for just non-responders, we're going to re-randomize them with equal probability to either behavioral modification or medication. And the strategy for that is that if we, so in this top part here, if you're someone who started with med and I re-randomize you to receive behavioral modification, that's known as augmenting, right? So I'm giving you something else, something different to what I gave you initially, versus if you started with med and I re-randomized you to have sort of a higher dose of med, that's an intensify strategy. And the same thing is true, you'll see down here, right? We still have augment and intensify as our strategies for stage 2, but here it's switched, right? So if you initially received behavioral modification and I re-randomized you to the augment strategy, that means that you're also going to receive medication then in stage 2, versus if you're re-randomized to the intensify strategy, that then you would be getting additional, so stepped up behavioral modification support. And for those responders, for all of the responders in this particular SMART, this doesn't always need to be the case. I actually got grant reviews where I re-randomized responders and someone told me that that wasn't a true SMART, but it actually is. You can re-randomize responders, but in this particular example, we're assigning all responders to continue with what they were initially assigned in stage 1. And then at the end of the school year, right, we end the trial, we collect our end of study outcome data, and overall there's 6 different experimental conditions corresponding to each one of these paths that someone could follow. Okay, so now let's go back to our 3 most common primary aims in a SMART, and let's talk about how we might actually in practice compare the main effective initial intervention options. Okay, so here's our aim type 1, and based on the colors I've presented here, I'm showing you how we're analyzing data. So in aim type 1, the research question that we're trying to address is whether on average, do children with ADHD achieve better end of school performance if they're initially offered medication or behavioral modification. And so we're comparing here all children who are initially assigned medication, so cells A, B, and C, to all children who were initially assigned behavioral modification, so cells D, E, and F, and we're averaging over subsequent treatments here. Okay, so I want to give a quick shout out. At the beginning of this, Brady showed you the PDHP PDHP website with all sorts of amazing workshops that they have archived, a wealth of resources. At the Data Science for Dynamic Intervention Decision Making Center, we also have a website that has a huge wealth of resources for you as well, including a robust code library. And so the part here I wanted to emphasize is that there's a whole library of code on different analyses that you might do with SMART data. I show some of them here, and I'm going to be showing you code from one of these tutorials. So we'll have my slides so you can see the code, but you can also go to our code library and follow along in the R Markdown as well. And I want to give kudos. The people who originally developed this code included Jamie Yap, Mason Fairlick, Dave Durham, John Ziak, and also Danny Almiral. Okay, so let's go into the steps for how we actually compare the main effective and initial intervention options. So we have, with any data analysis, right, we have some baseline steps, including opening whatever software package that you're going to be using or whatever software you're going to be using. Here I'm showing you code in R, reading in our simulated data. So there's simulated data for completing this tutorial on the D3C website, and also loading R packages. So for this particular tutorial, we're loading the dplyr package for data cleaning, we're loading ggplot2 for plots, and also loading the GEE package for the generalized estimating equations that we'll use. And so another initial step before we get into the analysis, right, is to visually inspect our data, right? That's a good step for anybody to go through. So here is a screenshot of some of the simulated data that we have to help you work through this tutorial. These first four variables are covariates. So the first one is oppositional defiant disorder diagnosis. Severity is severity of ADHD. Prior med is whether they had ever taken, before entering the study, whether they had ever taken medications for ADHD, and then race. So we have four different covariates in these data. We also have Y0, Y1, and Y2, which correspond to school performance at baseline, end of stage 1, and also end of stage 2. So school performance is our overall distal outcome. And then we have A1 and A2, which are intervention options at stage 1 and also stage 2. And you can see here that they're contrast coded to be -1 and 1. And then we have our response status at the end of stage 1, which is not something that we're going to look at for this AIM type 1, but it'll come back into play for when I show you the code for AIM type 2. Okay, so let's get into step 1 now. So step 1 involves contrast coding your intervention options if it's not already done, right? I just showed you that we've taken care of this step for you already in the tutorial or in the simulated data for this tutorial. The second aspect for step 1 is to grand mean center the covariates. So I'm showing here the code for how to do that. Our next step, step 2A, is to use a generalized estimating equation to estimate the parameters in the above regression model, where we have the expectation of our distal outcome, so end of school year performance, given the particular initial or stage 1 intervention option you received, and also specific observed characteristics X. So those are our covariates. And what we can see here is that we have this GEE GLM function where, again, we have our end of study outcome Y2 and regressed on A1, and then our covariates. And we have ID specified here in our data frame, and then here we have this std.err equals san.se to obtain our robust standard errors. Okay. So step 2B, we can look at our model results, and this line here in the red box corresponds to our intervention effect. But let's unpack this a little bit more. So step 2C here is to estimate key quantities of interest. And what we're doing here is we are estimating the mean of our end of study outcome Y2, given that you were, or the mean of our end of study outcome Y2 for those who were initially assigned behavioral modification, and the mean of the end of study outcome Y2 for those who were initially assigned med. So that's shown down here, and this is the code for how to do that. And then also estimating the main effect using the full sample. And what we can see here is that the estimated end of school year performance for those initially assigned behavioral modification was 3.26 versus 2.51 for those initially assigned medication. And so this suggests to us, right, that that behavioral modification was a better initial intervention option with respect to maximizing someone's end of school year performance. Okay, let's move now into AIM type 2. So for AIM type 2, we're comparing the main effect of second stage intervention options. So for this research question, we might state this something like, on average, for those who are responsive to the initial intervention, is it better with respect to end of study school performance to augment or intensify, right? Those are our strategies, and the way that we're operationalizing those strategies is if we're augmenting, we're giving the opposite thing in addition to what they were initially assigned. And if we're intensifying, we're just giving a stepped-up version of what they're initially assigned. And so we're comparing non-responders only in this particular AIM so those who are assigned augment versus intensify. So we're comparing cell B here and cell E to cell C and F. And we're controlling here for first stage intervention options. Okay, so to analyze these data for step 1, again, we're going to contrast code intervention options if you haven't already, or if that's not already done for you, and also centering each baseline covariate by its own mean. And here the key point is only among non-responders, right? Because this particular analysis only pertains to those who are non-responders. Step 2 is to use a generalized estimating equation to estimate the parameters in the regression model. And so here again, we see that Y2 is regressed on our stage 2 intervention option plus these covariates. And right, we can see here that they're centered just for non-responders. That's that underscore C and R. And again, here we're estimating, or we're obtaining robust standard errors. Okay, so step 2B, we can look at our model results. The intercept is not the intervention effect. A2, this should be shifted down one. A2 is the intervention effect, but we're going to unpack this more in the next slide by again estimating these key quantities of interest, including the mean of our end of school year performance, Y2, for those assigned to intensify in stage 2, so those non-responders who were assigned to have their intervention intensified versus those non-responders who were assigned to have their intervention augmented in stage 2. And so what we find here when we estimate those key quantities of interest is that the mean end of school year performance for those assigned to intensify in stage 2 is 2.295 versus the estimated end of school year performance for those assigned to augment is 3.13. So generally this is suggesting that augment is a better stage 2 intervention strategy for those who were deemed to be a non-responder to their initial stage 1 intervention at week 8. Okay, so let's move in now to AIM type 3, comparing embedded adaptive interventions. Okay, so does anyone want to take a guess at how many embedded adaptive interventions we have in this SMART? Anyone not in the front row? Walter's giving a hint in the front row. All right, so if you are thinking in your head, the answer is 4, you are correct. So we're going to walk through that now in the next couple of slides before we get into how to actually do the analysis here. Okay, so we have 4 embedded adaptive interventions, and this is the first one. So an embedded adaptive intervention is defined as you have something that you're doing at stage 1, right? And then you have one option for those who are responders and one option for those who are non-responders. That is how we are defining an embedded adaptive intervention. And so this is the first one. So start with med, and if you're a responder, you're assigned to continue at stage 2. And if you are determined to be a non-responder at week 8, you're assigned to have augment at stage 2, so getting med and behavioral modification. So that's our first adaptive intervention. And again, here you can see that I have the this written out decision rule is the exact same thing as what's depicted here in this what's depicted here in this image. Just two different ways to show the decision rule. Okay, here's another decision rule. So this is embedded adaptive intervention 2. So start with behavioral modification. Responders are assigned to continue at stage 2, and non-responders are assigned to have augmented treatment, right? So behavioral modification, and then at stage 2, we're adding medication. So that's our second adaptive intervention. Our third one is to start with med. Responders, again, are going to continue, and then non-responders we're going to intensify their medication dose. And our last adaptive intervention is that we're going to start people with behavioral modification. Responders, again, are assigned to continue, and for those determined to be non-responders at week 8, we're going to intensify their behavioral modification. So these are our, this is our SMART here, our experimental design, but these are the intervention designs on the right-hand side of the screen, and there's 4 that are shown here. Okay, so now getting back to AIM Type 3, where we're comparing embedded adaptive interventions. And so here a research question might look something like, is it better with respect to end of study school performance to start with med and then augment with BMOD for non-responders and to continue for responders? Or is it better to start with behavioral modification and then intensify behavioral modification for non-responders and continue for responders? And so here I'm showing the 2 different embedded adaptive interventions that we're comparing. So the first one is the one in red here, and the second one is this one in blue. Okay, so step 1 in this analysis, right, assuming that you had already visually inspected your data and done all of the initial good things to do, is again to contrast code. So this should be looking familiar at this point, if that's not already done for you, and then to center each baseline covariate by its own mean. And sorry, this is also, this was meant to be among everyone, not just non-responders. And then the next step is to create weights. And so here, we're going to introduce this idea of weighting. Let's see. And so basically, we're assigning weights differentially to responders and non-responders. And this has to do, if you look in this figure at the bottom here, this has to do with the different probabilities in which they're receiving their stage 2 intervention, right? So for all responders, right, they're all receiving continue. So that's a probability of 1 that you're going to continue if you're a responder. Versus for those who are non-responders, you have an equal probability of being assigned to the augment strategy versus the intensify strategy. And so in order to compare these embedded adaptive interventions, we need to assign weights. And so we're going to assign a weight of 2 to non-responders and a weight of 4, so a weight of 2 to responders and a weight of 4 to non-responders. And we're taking the mean of the sample who ended up in boxes A and B. And so here's the code for how to do that. Okay, and then step 3A. So in this weighting and replicating method, we're creating a new data set with replicated rows for responders, right? Because we have we're in the weights here, right? We are creating a new data set with replicated rows for responders. And so first, in order to do this, we need to save non-responders' observations into their own data set. And so we're generally restructuring the original data set such that instead of 1 observation per responder, the new data set will now include 2 copies of each responder's observation, and non-responders' observations will remain intact in this replication step. And so here in this first step, this is the code right here for saving non-responders' data into their own data set. So we're going to put them aside for a minute. And then what we're going to do is we are going to replicate the responders and inspect, here first we're just making sure that we have all the non-responders in their data, right? So you can see there's 1 row per person. And then we're going to look at just the responders and we're going to replicate them so that there should be 2 rows per person. And so when I originally showed you the data, A2 was coded as NA for responders. And so here for this weighting and replicating method, we're going to for 1 row for each responder, we're going to code A2 as -1, and for the other row, we're going to code it as 1. And so this here is the code for how to create the 2 copies of rows for these responders, and in general, how to create the data, the replicated data for the responders. And so we can inspect these data now. And so here I just highlighted participant 2, right? So instead, in our original data, we started with just one row for participant 2 who was a responder. But now through this weighting and replicating method, right, we have 2 rows for them. And here you can see that for one of their rows, again, A2 is coded as 1, and for the other row, it's coded as -1. So that all looks good. And then we're going to combine these data back together. And then with the full data set, we're going to estimate the parameters in the regression model. And so here we have this regression model showing that the expectation of the end of school year performance based on your stage 1 intervention option, and then also whatever stage 2 intervention option you received or that was received for non-responders, given your set of observed covariate values. And so again, we're using this GEE GLM function to estimate this model, asking for robust standard errors. And these are an example of what the results might look like here. And again, similar to the previous aims that I showed, we can estimate key quantities of interest. So we can, in this particular code that I'm showing you here, we get the mean end of study outcome under each of these 4 embedded adaptive interventions. So AI1 is starting with med, and then for non-responders, we're augmenting. AI2 is starting with behavioral modification, and for non-responders, we're again augmenting. And then AI3 is for those who started with med. Among non-responders in stage 2, they're assigned to intensify, and AI4 is those assigned initially to BMOD. And then at stage 2, the non-responders are assigned to intensify. And again, all responders are always assigned to continue. And so we can estimate these key quantities of interest and get what the means are for each of these embedded adaptive interventions. So this is what I'm showing you here at the bottom of the screen. And so we can see here that it looks like the embedded adaptive intervention that had the best end of school year outcome was this one here. So those who initially started with behavioral modification, and then among non-responders, they were assigned in stage 2 to have the augment tactic. And we can take this one step further by obtaining an estimated effect of one embedded adaptive intervention versus another. So for example, looking at the behavioral modification at stage 1 and then augmenting at stage 2 for non-responders versus starting with medication and augmenting at stage 2 for non-responders. And here we can see that behavioral modification was in fact a significantly better embedded adaptive intervention with respect to end of school year performance. Okay, so again, I just wanted to give a quick plug for all these awesome tutorials that are on the D3C website that you can go back through and work through the one that I just showed you, but also there's several other ones that you could also work through depending on your research goals. And so now I want to, so we've talked about 3 primary aims. And so now I want to talk to you about one secondary aim, and I'm not going to go into detail on the analysis code for this one for the sake of time, but I wanted to at least show you that this type of secondary aim also exists. And so this is known as a more deeply tailored adaptive intervention, which is an intervention that includes additional tailoring variables or decision rules relative to the adaptive interventions embedded in the SMART. And so response status, right, is a tailoring variable that we've been talking a lot about so far in this workshop. And so since it was included in the experimental design, we call that an embedded tailoring variable, right? But as researchers, we collect lots of other data, right? And so we might have all these other candidate tailoring variables that we could look at. And so getting back to this more deeply tailored adaptive intervention, it includes additional tailoring variables and also has the potential to lead to better outcomes by increasing personalization. So let's go through quickly what I mean by that. So this is an example of one embedded adaptive intervention where we're tailoring based on one variable. Again, this is what you've been seeing so far throughout this talk, is that we're tailoring based on response status at week 8. A more deeply tailored adaptive intervention might look something like this, where we're tailoring based on 3 variables, right? So we might assess at baseline whether the child had received medication in the prior year. And if the answer was no, then we would assign them to start with behavioral modification. Versus if at baseline we determined that they had received medication in the prior year, then we would start them with medication off the bat, right, in stage 1. So that is our baseline tailoring variable, or that's an example of how to use a baseline tailoring variable to determine what to do first for someone. And then here you can see this adherent variable here. So this is an example of a stage 2 variable that helps us determine what we should do next in stage 2 for non-responders. So people differ, right? And how, you might give them an intervention and tell them it's really important that they, adhere to it, right? That they take their medication every morning, or that they show up to their behavioral modification appointments with their therapist, right? But we know that this doesn't always happen in practice, right? People miss doses, people miss therapy sessions. And so we can calculate adherence, right? And so we might use adherence at stage 2. So how adherent were they over the past 8 weeks? If they were not adherent to whatever intervention they were, if they were not adherent to whichever intervention they were initially assigned, then we would assign augment, right? So let's try you on something different, right? Maybe it's just that this wasn't a good fit for you, so let's add something else and see if that might work better. Versus if they were a non-responder, but they were adherent, so they're taking or they're showing up to their behavioral modification sessions every time. Maybe it's just that they're a slow responder, right? It might be that they just need a higher dose, right, or longer to experience the particular intervention tactic. And so if they were adherent, we're going to assign them to intensify at stage 2. And so this is an example here of a more deeply tailored adaptive intervention where we're using additional sources of information about someone to decide what to do first, and also to decide what to do next for those who were determined to be non-responders at week 8. Okay, and so for this secondary aim, to specify this as a secondary aim, we can talk about this in terms of constructing a more deeply tailored adaptive intervention that maxes some outcome, such as end-of-year school performance, by examining whether a baseline variable is useful for tailoring first-stage intervention options. So I put baseline variable in brackets so that you could insert whatever that variable might be in your own work. And then also whether a baseline variable, or, depending on how complicated you want to get, multiple baseline variables, first-stage intervention, and also some intermediate variable are useful for tailoring second-stage intervention options. And so Q-learning is the method that can be used to address this type of secondary aim. I'm not going to go through the details of this in my particular talk here, but there is a really great tutorial for Q-learning, again, on the D3C website, so you're welcome to go through that if this is something that's of interest to you for your own work. Okay, so we've made it through quite a bit of this talk so far. We've talked overall about adaptive interventions. We've made it through quite a few of the bullets in the SMART section too, including we've defined sequential multiple assignment randomized trials. We've discussed why these SMARTs are useful. We've talked about an example or several examples of primary and secondary aims. And so now we're nearly to the end, but I wanted to talk about some SMART sample size considerations and also provide at least one example of another SMART design, just to show you that there's different ways that you might specify these experimental designs in your own work, depending on what your scientific questions are. Okay, so let's jump into the SMART sample size considerations. So I first want us to talk about sample size if you're looking to do a pilot, right? We're all here to learn in this workshop, and so I'm guessing most of you aren't at the phase of doing a full-scale SMART, so let's start off first at how we might think about sample size for a pilot. So the goal of sample size considerations for a pilot SMART pertains to preparing ourselves for conducting a full-scale SMART. And success is defined by a few things here, including having an adaptive intervention that is well operationalized. So what I mean here is that your protocol is airtight, right? You have everything documented. All of your tactics are documented, how they're implemented. All of that is written out and airtight. We're also defining success by having an adaptive intervention that is deemed to be acceptable and feasible by key people of interest, right? So you've had people try out one of the experimental conditions in your SMART, and generally they're telling you that it's acceptable to them, right? And you're seeing that it's feasible. And so if that's not the case, right, maybe we need to keep piloting. And then the third thing is we're looking for evidence that the proposed trial design is feasible, right? So this is different. This is pertaining to that we as researchers can actually conduct this thing, right? That our randomizations are going as expected, right? It's not that, somehow all non-responders got randomized to intensify somehow, right? Like that would be a non-feasible thing, right? Something went wrong there. So we're making sure that the way that we're implementing this trial as researchers is going as expected. And so with these aspects of success in mind, when we're thinking about sample size, we want to plan this sample size to ensure that we can assess feasibility and acceptability within each cell with sufficient number of participants. And so again, assessing feasibility and acceptability for our key people of interest who might be students, they might be teachers, they might be people receiving some sort of health intervention. And so we want to generally make sure that we have enough people within each cell of our experimental design so that we can assess these different metrics of success. And so to calculate a total sample size, a scientist needs to choose 3 different things. So first we have this M quantity, which pertains to the number of individuals required in each cell. So maybe as a scientist, I want to have aim for 10 people in each cell or each experimental condition, or if I have a really small pilot grant, maybe I want to aim for 3 people in each experimental condition. So that's the first thing that we need to assess, or that we need to assign. The next one is this K value, which is the desired probability that at least M participants will fall into the cell. And then this Q term pertains to a guess of your anticipated non-response rate. So do you think around 50% of people will be non-responders? Do you think it's more like 70%? Some sort of guess about what your non-response rate will be. And so once you have ideas for each of these quantities of interest, there is this really nice shiny app for calculating sample size based on each of these quantities. And I have a QR code here. And it's really cool too. I've shown you one particular type of SMART design, but this shiny app has calculators for lots of different SMART designs. So it's a pretty cool tool. So I encourage you to check this out. Okay, so now moving on to, let's say we've conducted our pilot, everything is feasible, everything is acceptable. We're, NIH was in our favor, we got this big grant. So now how might we think about sample size for a full-scale SMART? So the first thing we want to think about here is selecting your primary aim or primary scientific question, right? And then you're going to base sample size on whatever that primary aim is. And so again, here I have linked the aim types that we've talked about. It doesn't necessarily need to be one of these, but these are amongst the ones you might choose from. And again, there's so many different types of primary aims and different configurations for SMARTs that I am not putting up specifics here for how to calculate sample size, but referring you again to our code library that we have no less than 5 different tutorials for sample size calculations on different types of SMARTs. So there's a lot of really robust resources here for you to check out. Okay, so now we're nearly to the end. Thank you all so much for your attention so far. I wanted to end here with providing at least one example of another type of SMART. I mentioned earlier that the example that I've been drawing from so far was an example of a prototypical SMART, right, where responders were always assigned to continue in stage 2, and we had 2 different options for non-responders at stage 2. But there's other ways that these experimental designs can be implemented, and so I wanted to show you at least one other one. So again, this is the one that we've been looking at so far, where responders continue and then non-responders are either assigned to augment or intensify. So here's another one from the Extend study. And so this one is one of those examples that, again, I alluded to earlier on in the talk, where we randomize folks to one of two intervention options at stage 1, and then at stage 2, and this one also happens to be week 8. It doesn't always need to be week 8, right? The way that you determine this is how long or how quickly you think that you can get a good estimate of whether somebody is responsive or not. So it doesn't need to be week 8. This one just also happens to be week 8. And then at week 8, both responders and non-responders are re-randomized. And so there's one grant proposal that I'm currently working on where we're also re-randomizing responders because we're trying to identify someone's optimal challenge. And so we're trying to see if we can step up their physical activity goal or if we had already found it in stage 1. And so there's different reasons why you might also want to re-randomize responders at stage 2. And in this particular study, the scientific questions that they were really interested in pertain to what measure of drinking behavior best reflects non-response to this naltrexone medication, what intervention strategy would be useful among non-responders to this NTX intervention, and then what maintenance strategy would be useful among non-responders. Okay, so that's just one. There's many others, and so I provided here at the very end of my slides lots of resources and papers if you're super jazzed about this topic and want to go forth and implement this into your research program. I have lots of papers linked here, both methodological papers and also domain science papers that have examples where adaptive interventions are being developed. So I hope these resources are useful. And with that, I think that concludes my slides. All right. Thank you all so much for your attention. Okay, so now we have a 10-minute break. Is that what we were thinking? 10 minutes?
The issue that we're having here is it's just very.
Okay, so 10 minutes means that we're all coming back at 2:07. Is that right? Yeah, 2:07. Or sorry, 2:17. It is 2:07. All right. So we can.
Show you what's going on.
Thank you. For the first time ever, I ended early. Can't believe it. Which works out because we're running late. So.
Do you want the setup? Okay, now I would take that.
And I would take this.
Thank you for letting me use your